Students, this is the circle problem video for our last study guide. There are 4 sections to this. You need to make sure you have these pages memorized. We're going to start here with problem number 4. We want to sketch a net of each solid. Sketch a net, which means we're going to unfold this. And if you need to, just take a few seconds and visualize a pyramid in your hand, and then you unfold it. I'm going to be unfolding like bananas. I'm going to start with the base here, which is a pentagon. I'm going to pull over what measures we have. Our apothem here is 5.5. And our edge length is 8 all the way around. And then we are told that this edge right here, which is our slant height, is 11.4. So when we unfold it, it's going to be the height of the 5 triangles. And so when you unfold this slant height, it becomes the height of the triangle, which in this case is 11.4. And that is the process of making a net. Okay, in number 16, we're given a net, and we want to fold it back into a solid. So the first you need to identify is, what kind of solid is this? It's going to be one of 4 solids. One of 4. Is it a cone? Is it a cylinder? Is it a pyramid? Or is it a prism? That's the first thing you want to identify. A cone and a pyramid both have only one base, and this has 2, so that eliminates these 2. Cylinder, the bases are circular, so we have a prism. So we're going to start by drawing one of our bases, and I'm going to start by drawing the top base. You want to make it kind of squishy because we're making it 3D. And then we're going to pull down each of these sides and use that to draw your bottom base. You want to dot those lines that technically we can't see. And our edge length here is 10, so all of these are 10. And our apothem is 6.9. So drawing into the middle, the apothem is 6.9. All of this edge length is 10. And our height, the distance between the bases, is 14. So to make this easier, just physically feel that this pattern's in your hand and then fold it up. Okay, it says number 3, find the perimeter and the area of the parallelogram. Find the perimeter and the area of the parallelogram. So let's write our equation for perimeter. To find the perimeter, we're simply going to add up all the edges. So our perimeter is simply going to be whatever the green is, times 2, because there's 2 of them, plus whatever the red is, times 2. That would be the perimeter. Area is going to be the length of the base times the height, which is this segment right here. So the problem is we have some items missing. Let's take a look at what we have missing, and let's take a look at what we have. The perimeter is easy. We actually have both of these. So we can put 24 there, and then the red edges is 20, which means our base here is also 24. So the only thing we're really missing is the height to finish this problem. Let's look at what kind of information we have. We have a right triangle, and we have a 60 degrees. Pull that triangle out here, and this is 20, this is 60 degrees. We have a 30, 60, 90 triangle. There's a couple ways you could do this. We could use SOHCAHTOA, or we can use a 30, 60, 90 table. I'm going to use the 30, 60, 90 table. This is my hypo, this is my short leg, my long leg. I write the table out, short leg, long leg, hypo. Whatever the short leg is, the hypo is 2 times the short leg, and the long leg is the short leg times √3. Or, if I want, I could call that x, and I would be working with the opposite and the hypo, which means I would use sine of 60 degrees equals the opposite, which is x over 20. Either way, you could find that height by solving for x using SOHCAHTOA or solving for the long leg in a 30, 60, 90. Once you have the height, find the area. Perimeter, you just add it up. Number 9 here. Our goal is to find the area. And we have kind of an odd shape here. So the first thing you should do with odd shape items is break it down into familiar shapes. So the easiest one to break it down, of course, you see that triangle there. So we have a triangle. I'm going to pull this out so you can see it. And then this we have 2 parallel sides and 2 non-parallel sides. Which means that technically is a trapezoid. We have a slightly shorter and then a slightly longer one. So to find the area of a triangle is going to be base times height over 2. And to find the area of the trapezoid, we average the bases. So base 1 plus base 2 over 2 times the height. So what you want to do is count the units here. The height here, we come back to here, we count it straight down. 1, 2, 3. Our height is 3. Our base, we start at -3 and we go to +3. 1, 2, 3, 4, 5, 6. So our base here is 6. You're going to plug this into the height, this into the base, and the length in our trapezoids, again we go from -3 to +3. 1, 2, 3, 4, 5, 6. So our base 1 is 6. Our base 2 starts at -3 and goes to +4. 1, 2, 3, 4, 5, 6, and 7. So our base 2 is 7. And our height, if I'm here at -3 and this is -3, that would make that a perfect right angle. So we know our height is 1, 2, 3, 4, and 5. That is going to be our height. So put our base is 1, our base 2, and our height. We want to find the area of everything and simply add it up. Number 13, it says find the volume of the pyramid. Round everything to the nearest tenth. So the first thing we're going to do is write the equation for volume. Volume equals area of the base times the true height over 3. Notice I've used a capital B. Whenever we have a capital B, we always shade the base so we can identify what shape it is. So you want to shade the base. And our base is a rectangle, so we're going to go length times width times the height over 3. So let's identify where this height is. Height goes from the apex to the center of the base, and notice we don't have it here. Let's look at what we do have. We do have the slant height going down the face. Let me pull this out. That's 20. And we do have the apothem from here to here, which is going to be half of 24, which is 12. So now we circle, plug, chug. Our length is 30. Our width is 24. Our height we don't know yet. And then we have it over 3. So from this point, you're going to use the Pythagorean theorem to find the height. Then you plug it over here. You watch for units so that your final answer is going to be volume equals, and then it's going to be millimeters cubed. I'll trust you to finish there using the Pythagorean theorem to find the true height. Go on to our next problem. Let's take a look at what we're supposed to do. It says we're supposed to find the surface area of the prism. So we're making nets and finding the surface area. The most important part of this process is very carefully unfolding everything. So we're going to start by unfolding this 7 here, which makes that 7. Now I'm going to fold out this trapezoid here. That's 6. That's going to be 10. And then this edge, we don't know. We're going to call it X. At some point, we're going to need it here. Okay, now let's do our connecting. So we can see here that this connector from here to here, the orange, that's 13 and 13. So that's 13 and 13. And then we're going to come up this back side here to our tens, and the back is a rectangle. These edges must meet, so these have to be 10, because if you fold it back, they have to match up with this 10 here and that 10 there. And then it's still 13 going this way. And then we see here we have the two pinks. So that means when you fold this out, this is 6 and 6 as well, still. And this connector again is 13. So the problem is we still have up here, we have an unaccounted for rectangle, and we know what's width is 13, but the problem is we don't have this right here. It's unknown, which is the same edge as this X. So remember, the key to everything is a right triangle. And obviously at this moment you don't see a right triangle. But if you don't see a right triangle, you can always create a right triangle. For example, we know that there's a right angle here. So if I just take that and make a parallel right angle segment, behold, I have a right triangle. I'm going to bring that 7 up. And if from here to here is 6, and that's 6, that means I can find this little piece here, because the whole thing is 10 minus 6. That makes it 4. Now we have sufficient information to find our X. Again, you're going to use the Pythagorean theorem to find X. Once you have X, you're going to plug it in here. The area for a rectangle, area equals length times width. The area here, area equals length times width. This area, area equals length times width. This area, area equals length times width. And this is a trapezoid, so that is area is base plus base over 2 times the height. And then you're going to have 2 of them. And remember, the bases are the parallel sides, so that's going to be 6 and 10. And your height is at a right angle. So you're going to finish all your math here, showing all your work, solving for X to be able to get that last red rectangle. Number 25. It says Dolores is standing on horizontal ground with the base of the Statue of Liberty in New York. The angle formed by the ground and the line segment from her position to the top of the statue is 26.3 degrees. The height of the statue is approximately 93 meters. Find her distance from the Statue of Liberty to the nearest meter. Okay, let's underline our keywords and phrases. First off, she's standing on horizontal ground, level with the base of the Statue of Liberty. There's an angle formed from her position to the statue, and that's 26.3 degrees. The height of the Statue of Liberty is 93 meters. Find her distance from the Statue of Liberty. That's going to be your X. I'm going to set the timer for 1 minute. To the best of your ability, I like to see if you can interpret this into a diagram without any help. So 1 minute, try to take those underlined words and phrases and try to get a diagram. Okay, let's see how you've done so far. So we have the Statue of Liberty. We're going to pretend I can actually draw. Use your imagination. That's the Statue of Liberty. And then here we have Dolores standing at level with the Statue of Liberty. There's Dolores. And the segment from her to the Statue of Liberty that angle right there is 26.3 degrees. And we're told the height is 93 meters. And our goal is to find the distance. So that's from here to here. That's our x. So now we do have need do after we label. So that is going to be our opposite side. This is going to be our hypo. This is going to be our adjacent. So have, need, do. We have the opposite side, and we need the adjacent side. We have an O and an A. You ask yourself in sol, ka, toa, what goes with this? And the answer is toa. So I write out the equation, tangent of theta equals opposite over adjacent. We're going to circle plug chug, tangent of angle theta. So we have tangent of 26.3 degrees over 1 equals our opposite, which is 93, over our adjacent, which is x. You cross multiply and you solve for x. Don't touch a calculator until x is by itself. Number 26. Says a water slide is 400 yards. A water slide is 400 yards long with a vertical drop of 36.3 yards. Find the angle of depression of the slide. Okay, so let's draw. This is basically one of those straight shot water slides. So we have, there's your ladder. And it's 400 yards long. And it has a vertical drop, so that gives you a hint that that's straight up and down of 36.3 yards. It wants to know your angle of depression. Now this is, remember, depression starts at a horizontal and goes downward. So be very, very careful here. Your angle of depression is not that yellow. The angle of depression, you draw a straight line out going downward. We would call that the angle of depression. And if we were to trace this, our angle of depression that we want right there, that green, if you trace it, the angle of depression is going to be the same as this angle of elevation. So I'm going to call this our x degrees. From this x, we're going to label, we have both the opposite and the hypo. So opposite and the hypo. We need the angle. So I've got an OH, and in so, ka, toa, I know I'm going to use sine, but we're looking for the angle, so this is the time we use the inverse sign. Inverse sine, opposite over hypo, will give us that angle theta. Okay, this next portion we're going to be talking about similarity. For number 2, we're going to test to see if they're similar. Remember congruent angles, ratios equal. So we use this ratios equal to test for similarity. So step 1, I'm going to test these lengths, 108 to 54. And I ask myself what goes into both of those. I'm going to try dividing both by 9. So 108 divided by 9 and 54 divided by 9. We know this is 6. 9 goes in there once. 9, 18 left over. 9 goes into 18 twice. So if I do that, that's a 12 to 6, but I can take that one more down. Of course, it's a 2 to 1 ratio. 54 goes into 108. So now I'm going to try the other, but be very, very careful here. If I use 120, that's the whole diameter. I have to use the same whole diameter over here. We were told that radius is 20, which means my diameter here is going to be 40. So now I test 120 to 40. Now I know 40 goes in here 3 times. 40 goes in there 1. So this is a 2 to 1 ratio. This is a 3 to 1 ratio. So we're going to say, no, these are not similar. Why? Because the ratios are not equal. If the ratios were equal, then yes, they would be similar. Says each pair of the figures is similar. Find the scale factor from the left to the right, then find the ratio of the surface areas and the ratio of the volume. So we're finding 3 things. Now that's in order. That scale factor is in the first dimension. We're going to find that. And then we're going to find the ratio of the surface areas, which is in the second dimension. And then we're going to find the ratio of the volumes, which is in the third dimension. And remember, the key to this is understanding that dimensions impact exponents. Dimensions impact exponents. So in the first dimension, it's like saying x to the first, y to the first. Second dimension would be x squared and y squared. Third dimension would be x cubed, y cubed. Step 1, we're already told they're similar, so let's just figure out what our scale factor is. So I'm going to go here. That's my radius. So my radius here is 7, not 14. So I first check. I have 7 to 63. I reduce it as far as I can. And that's going to be 7 goes into 7 1 time, 7 goes into 63 9 times. So that's called our scale factor. It's the ratio of the sides, so it's a 1 to 9 ratio. Now, my area ratio is going to be 1 squared and 9 squared. 1 times 1 is 1. 9 times 9 is 81. So the ratio of my areas is actually 1 to 81. Volume is going to be 1 cubed to 9 cubed. So 1 times 1 times 1 is 1. 9 times 9 is 81, times 9 again. And I get 729. And this would be the ratios of my volume. So let's think about what happened here. If we take an edge length and we stretch it by 9 times, Our edge length gets 9 times longer. Our area is going to get 81 times more, and our volume is going to get 729 times more. Okay, problem 20. It says each pair is similar, so we're told they're similar to begin with. Use the information. We're going to find the scale factor, which is one dimension, from the left to the right. Okay, let's look at what we're given. We're given the surface area of both. Area is in the second dimension. So in the second dimension, we're going to find this ratio, 175 to 576. And we're going to reduce as far as we can into the second dimension. So 175, 576, 175, 567. Let's check to see if they're divisible by 3. 1 plus 7 is 8, plus 5 is 13. 5 plus 6 is 11, plus 7, that's 18. Okay, they're not divisible by 3. They're not divisible by 7. Let's double check here. 567, is it divisible by 7? It is. Okay, so we have 175 divided by 7, and we're going to get 25. And then 576 divided by 7, and we get, 567 divided by 7, and we get 81. So the ratio of the surface areas is 25 to 81. Now that's in the second dimension. We want scale factor, which is in the first dimension. So basically what we have is we have x squared and y squared. We want what would x be and what would y be. So we have x squared is 25 and y squared is 81. Use that information just to find the x and the y, which would be the scale factor. Last one, it says the scale factor between two similar figures is given. The surface area and volume of the smaller figure is given. Find the surface area and volume of the larger. Okay, so we have a small versus larger. We're not even told what they look like, but we know that the scale factor, or 1D, is going to be 1 to 9 ratio. Our 2D ratio, and now we're going to do our 3D ratio. Our 2D ratio is going to be 1 squared, so it's 1. Let's keep my colors consistent. And then here is going to be 9 squared, which of course is 81. Our 3D ratio is 1 cubed, which is still 1, and then 9 cubed, and we did that one up here already, 729. Okay, we are given the surface area of the smaller. So let's write over here the small to large. We're given the surface area, and we're also given the volume, small to large. So the trick here is just trying to figure out which proportion. Now, the actual surface area of the smaller figure is going to be 17 feet squared. we know if it's area, we have to use this ratio right here, 1 to 81. We use that to solve for the area of the larger shape. The volume of the smaller is 19 feet cubed. So for that one, I use this ratio. 1 to 729 equals 19 to, let's not use x again, we'll use y this time, to find the volume. So this is going to get you the volume of the larger, and this, the surface area of the larger. The rest are word problems. You get to do these ones on your own. You're welcome to come see me at lunch or after school if you'd like extra assistance.